Bristol Community College, Mathematics with Dan Avedikian, Math 060, Topics in Developmental Mathematics, Section 4.2, Problem 13. This is Section 4.2, Problem 13. It says the given triangles are similar. Find the length of the unknown side. So we have two triangles. The unknown side is the bottom of the larger triangle. So what you do is you set up a proportion. So you can do bottom of the small triangle to bottom of the big triangle would be 16 to n, or 16 over n. Set that equal to the right side of the small to the right side of the big would be 20 to 25, or in other words, 20 over 25. So now when you have two fractions that are equal to each other, what you do is you cross multiply and divide. So one way, you're going to get 16 times 25, and the other way, n times 20, and those should be equal. N times 20, we can write 20n. 16 times 25 is fairly big. You might need to multiply that out the long way. So 25, 16, multiply. 6 times 5 is 30. Write the 0, carry the 3. 6 times 2 is 12, plus the 3 more that we carried is 15. And then we can put a 0 to hold our place. 1 times 5 is 5. 1 times 2 is 2. And if we add 0 plus 0 is 0, 5 plus 5 is 10, write the 0, carry the 1. 1 plus 1 is 2, plus 2 more is 4. So 16 times 25 is 400. So we have 20n equals 400. So now what we want to do is divide the 400 by the number in front of the n. And I can see that's 20. If you don't see it easily, write it out the long way. 20 divides into 400. 20 goes into 4, it doesn't fit. 20 into 40 goes twice. 2 times 20 is 40. Subtract 40 minus 40 is 0. Bring down the next digit. 20 goes into 0, 0 times. 0 times 20 is 20, 0 remainder. It goes in evenly. So I could see it easily enough. If you can't, it takes a few seconds. So the length of the unknown side is 20.